Right now, the universe is full of unknowns, mysteries, and other perplexions that have had the world's most renowned scientists scratching their heads. Questions like what exoplanets have suitable atmospheres for life, what goes on around black holes, and even what was going on towards the very beginning of time itself are things that we have sought answers for centuries. Fortunately, many of these long, elusive questions may finally be solved with a new telescope that NASA launched last year, the James Webb Space Telescope. Now, before we get into this incredible telescope and the mysteries it may unravel, I would appreciate if you would like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so what is this telescope, which I'll be calling Webb for short since I don't want to stumble over words more than I already do, and what makes it so amazing? Well, in order to get into that, we need to talk about its predecessor, the renowned Hubble telescope. Hubble was, and is, a great telescope in its own right, taking some of the most incredible pictures of the cosmos we've seen to date. However, Hubble's scope was limited. It was built in the 90s and it was rapidly deteriorating. So as far back as the mid-2000s, there were plans for a new telescope to be built. Unlike Hubble, which sees in visible light, the plans for this new telescope were to see in the infrared. Essentially, the color of light is dependent on the wavelength, with violet being about 400 nanometers and red being a slightly longer 700 nanometers. Infrared light has a wavelength longer than this, so human eyes can't pick it up. However, seeing in the infrared has a whole host of advantages that visible light doesn't when it comes to astronomy, advantages that I'll discuss later when I'll talk about what exactly the telescope can do. Anyway, another plan for this telescope was to take it to a so-called Lagrange point, which is essentially a point about 1 million miles out from Earth, where the gravitational forces of the Earth and the Sun effectively cancel out, essentially keeping the telescope in place relative to both objects. This was risky since unlike Hubble, which could be repaired due to its location in low Earth orbit, any damage done to this telescope would be irreparable for decades or even longer. Nonetheless, the plans continued. Webb was originally slated to launch in the mid-2010s, but a series of delays ensued thanks to funding, the pandemic, and a whole host of other issues, which is honestly typical for space missions at this point. Just ask Artemis. Finally, on Christmas Day 2021, the telescope left Earth. The journey to the Lagrange point itself was a whole other complicated process, the details of which I won't get into here. But to keep it simple, it was essentially a high-stakes unfolding of origami. Why couldn't they send Webb unfolded? Well, the telescope is nearly 70 feet in diameter, way too big to fit on a conventional rocket. One detail I will mention is that the process was done unexpectedly efficiently, and that it used less fuel than expected. As a result, while NASA originally expected to operate for 10 years, it is now expected to keep running for 20 years or even longer, which, yay for science. After arrival, it spent about 6 months testing out equipment and other essential functions, and finally started collecting data in June of 2022. But what is this data? Well, most of you have probably already seen Webb's jaw-dropping images. If you haven't, I'll link an album down in the description. The images themselves are some of the clearest images of space humanity has ever seen, and they are even able to pick up some really cool space phenomena. For example, the light from distant galaxies being distorted due to the gravity of much closer ones, an interesting case of gravitational lensing. But cool space images are the bare bones of what Webb can do. Remember when I said that Webb could see in infrared light? Well, the reason behind this is that Webb could peer further back into time than ever before. You may have heard that when you look at stars in the sky, you aren't seeing them as they are now, but as they were hundreds of years ago. This is because light from a star, say 400 light years away, needs 400 years to actually get to Earth. As a result, you see the star 400 years ago, as the light that was emerging from the star at that time is just now hitting your eyeballs. It is possible to take this to the extreme, with galaxies being 13 billion years or older being on Earth. For reference, the universe is 13.798 billion years old, give or take a few million years. The issue with visible light is that for a few 100 million years after formation, the universe was opaque to this spectrum, consisting of a really, really dense plasma. Infrared light, however, is able to shine through the fog a little better, allowing us to see even older phenomena. Early data from the telescope may even refute the possibility of the Big Bang ever happening. But this is based on small scraps of evidence and would need significantly more testing to actually verify. On the off chance this is true, however, it would undoubtedly be one of the biggest shifts in cosmic thinking in centuries. One more thing Webb can do with infrared light is analyzing exoplanets, or planets outside of our solar system. Again, where visible light falters, infrared light shines through. By combining the infrared light with some models by cool science people, we are able to get a rough guess on what the atmospheres of those planets might look like. This can obviously be taken much further, as it is possible to detect certain elements in said atmospheres that signal at the possibility of life on the planets below. For example, we have found carbon dioxide in a gas giant, which, while not necessarily indicative of life, is still a monumental discovery that puts us on the right track. There are so many more things this telescope can do, and even other details like how the telescope is made up that I can't cover here, so I might explore those details in a future video. Until then, I would appreciate if you would like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks, and have a great rest of your day.